Hi everyone, I am Arun JULKA. Today in continuity part 3, we will discuss continuity of modulus function. Example 1. Test the continuity of function fx equals to in mod x minus 1. If we put mod x minus 1 equal to 0, we will get the value of x is 1. So the turning point of the function is 1. So fx equals to minus of x minus 1 when x is less than 1 and is equals to x minus 1 when x is greater than or equal to 1. First we calculate left hand limit x tends to 1 negative, and we'll take function minus of x minus 1 because x is less than 1. Put x equals to 1 minus h, x tends to 1, so h tends to 0. Replace x by 1 minus h, and after calculating we'll get left hand limit equal to 0. Now right hand limit x tends to 1 positive. And we'll take function x minus 1 because x is greater than 1. Put x equals to 1 plus h, x tends to 1, so h tends to 0. Replace x by 1 plus h, and after calculation, we'll get right hand limit equal to 0. And the value of function at 1 minus 1 equal to 0. So left hand limit equals to right hand limit equal to value of function at 1. Thus, function is continuous at x equal to 1. Next example, test the continuity of function fx equals to in mod 2 minus x. If we put mod 2 minus x equal to 0, we'll get value of x equals to 2. So the turning point of the function is 2. So fx equals to 2 minus x when x is less than 2 and equals to minus of 2 minus x when x is greater than or equal to 2. First we calculate left hand limit x tends to 2 negative, and we take function 2 minus x because x is less than 2. Put x equals to 2 minus h, x tends to 2, so s tends to 0. So limit s tends to 0, replace x by 2 minus h. And when we put limit s tends to 0, we'll get left hand limit 0, right hand limit x tends to 2 positive, and we take function minus of 2 minus x because x is greater than 2. Put x equals to 2 plus h, x tends to 2, so s tends to 0. Limit s tends to 0, replace x by 2 plus h, and after calculation we'll get right hand limit equals to 0. And the value function at 2 minus 2, and minus outside the function, so we'll get 0. So left hand limit equals to right hand limit equal to value of function at 2. Thus, function is continuous at x equals to 2. Last example. Test the continuity of function fx equals to in mod x minus in mod x minus 1. If we put the both mod equal to 0, in first we'll get x equal to 0, in second we'll get x equals to 1. So the turning points are 0 and 1. So if x is less than 0, then we get value of function minus x plus x minus 1. If x lies between 0 and 1, we'll get the value of function x plus x minus 1. If the x is more than 1, then we'll get the value of function x minus x minus 1. And after calculation, we'll get the value of function minus 1, 2x minus 1 and 1. Now we have two turning points, 0 and 1. So first we calculate for x equal to 0. First we calculate left hand limit x tends to 0 negative, and the value function is minus 1. And the right hand limit is limit x tends to 0 positive. And we take function 2x minus 1. Put x equals to 0 plus h. X tends to 0, so s tends to 0. Limit s tends to 0. Replace x by 0 plus h. And after calculation we'll get value of right hand limit minus 1. Value of function at 0 is twice of 0 minus 1, which is equals to minus 1. So left hand limit equals to right hand limit equal to value of function at 0. Thus function is continuous at x equal to 0. Now we check function at x equals to 1. So left hand limit is limit x tends to 1 negative, and the function is 2x minus 1. Put x equals to 1 minus h. X tends to 1, so s tends to 0. Limit s tends to 0, replace x by 1 minus h. And after calculation, we'll get the value of left hand limit 1. Now the right hand limit is limit x tends to 1 positive, and the value is 1. and the value of function at 1 is 1. Since left hand limit equals to right hand limit equal to value of function at 1, thus function is continuous at x equals to 1.